Hello learners, this is Education Online Program. With you is teacher Rose Hezekiah. I'm here to present for you a lesson in chemistry for senior 1 and 2. And our topic for today is about the periodic table. We will be looking at group 8, which is the last group in the periodic table, because in the periodic table we have like from group 1 up to group 8. So group 8, they are mostly known as noble gases. So because they rarely combine with other elements. Sometimes they are called noble gases, or we call them inert gases. Noble gases or inert gases. They are called noble gases or inert gases because they rarely combine with other elements, and they are mostly found in uncombined state. Under normal conditions, they don't combine with other elements in nature. So in nature, they are found in uncombined state. In nature, that is naturally they exist in uncombined state. Because their reactivity is low, that is, I said, under normal conditions they rarely combine with other elements. So we have the first member of group 8 is helium. So helium is an exception. It is the only element that has got 2 electrons, but it has got the same properties as the rest of the elements of group 8. So all members of group 8 has got 8 electrons in their outermost energy level, with exception of helium that has got only 2 electrons. So helium is less dense. Then we have neon, we have argon, then we have krypton, we have xenon, and then we have radon. So we have helium is less dense radon. Helium is less dense than air. Helium, symbol He, is less, that is, it is lighter than air. So helium is used for inflating. It is mostly used for inflating balloons of all kinds. That is balloons for entertainment, and then balloons that are used for application of several things, like sporting events. So helium balloons also can be used to lift instruments into the upper atmosphere, for example, to measure atmospheric pressure. So all members of group 8, they exist as gas. They are gases. are gases, or they exist in gaseous state. So let us look at the uses of the noble gases. We say that in nature, mostly they exist in uncombined state. They don't react with other elements under normal conditions, or we say their reactivity is very low. So we have neon. Neon is used for, as we said helium is less dense than air, and then it is used for inflating balloons of different applications. Then we have neon is used to light up bulbs, it is used in lights of advertisements, lights that are used for adverts. Also, neon or any other noble gas can be passed through glass tube that makes up sign, or electricity causes the noble gases to glow. For example, when we pass electrical light through helium, then helium glows and gives us yellow color. When electricity is passed through noble gases in a tube, these noble gases glow. So helium glows yellow, neon glows red orange, and then argon produces a bluish violet color. Krypton used with nitrogen in ordinary light bulbs. We have krypton plus nitrogen, which is not a member of group A. They are used together in the ordinary light bulbs that we use in our houses. They are used in ordinary light bulbs. So we have bulbs that is made up of a mixture of argon. If we need quality bulbs, that can sustain, that can live for a long time, then those bulbs may contain a mixture of argon, krypton plus xenon. So most of the noble gases are used in electrical applications. Krypton lights are the lights that are used at landing stripes in airport. Krypton lights are lights that are used in landing stripes at the airport. we have radon. That is the last member in group 8. Radon is a radioactive gas. Radon is a radioactive gas, and we know that all the radioactive elements are dangerous to our bodies. Their exposure to the human body or any living organism is of hazard. So it is a radioactive gas, and it can be produced naturally as a result of uranium decay. When uranium decays, or we said when uranium breaks down in the earth crust, one of the products of uranium decay is radon gas. When uranium breaks down, or we said when uranium decay in rocks, so one of the products of this uranium decay is what we have is what is called radon gas. And this takes place normal or naturally. So if radon enters or seeps into a home or a house, the gas can be harmful because it will continue to emit radiation, and when people breathe in radon, it can cause infectious diseases to human beings like cancer. So we know that all or most all of the radioactive elements affects the human body. So I have elaborated about the periodic table. Is started from the alkali metals, then the alkaline earth metals, then the carbon family, that is group 4, then you have group 7, the halogens, and then group 8, the noble gases. So let us look at a winding exercise about the periodic table. A winding exercise about the periodic table. So we have, for example, we have a sketch of the periodic table. A sketch of the periodic table. So this is an example of the periodic table. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So we know that the periodic table have got 8 groups. So the groups are assigned Roman numbers. We have 1, 2, 3, 4, 5, 6, 7, and then we have 8. Then we have the periods, period 1 and then period 2. So we have 3 elements. We have W, and then we have X, and then we have Z. So let us imagine that this is a sketch of the periodic table with 8 groups: 1, 2, 3, 4, 5, 6, 7, And then we have period 1 and 2. We have element W in group 1, and then X in group 3, and then we have Z in group 7. So the question comes that write the formula of the oxide of W. Question number 1 is write the oxide, write the formula of the oxide of W. That is, when W reacts with oxygen, it gives us a metal oxide, because we say that all members W, first of all, W falls in group 1, and we know that all members of group 1 are metals. So the metals react with oxygen to give us a metal oxide. So if we assume that W can react with oxygen, this is W, and then we put here oxygen. So the rules for writing chemical formulas is that we say first we write the valencies. So we know that W has got the valency of 1, and then oxygen has got the valency of 2, because we say that valency is defined as the number of electrons gained, shared, or lost. So oxygen is in group 6. It is having 6 electrons in its outermost shell, and then it needs 2 electrons in order to attain the noble gas configuration, which means the valency of oxygen will be 2. Then in the second step is that we exchange the valencies. We bring the valency of oxygen to W and the one of W to oxygen. So the oxide that we have will be W2 oxide. So this is the oxide that will be formed when W reacts with oxygen. Then question number 2 is write the formula of the compound formed when X and Y, when X reacts with Z. 2 is you write the formula of compound formed when X reacts with Z. So we have X is in group 3 and Z is in group 7. So X is in group 3, which means the valency of X is 3, and Z is in group 7. Z is in group 7. The valency of Z will also be what? 1, because Z wants only 1 electron to attain the noble gas configuration. So we exchange the valencies. So our compound will be X, Z, 3. This is the compound that will be formed between X and Z. The compound that will be formed between. So for X to react with Z, we need 3 atoms of Z that will combine with only 1 atom of X. And X is losing 3 electrons. So these 3 electrons will be distributed to the 3 atoms of Z. So we have another question that the atomic number of P, write the formula of the ion. Write the formula of the ion form. So we have Z and X again. W and Z. W and Z. So if W reacts with Z, the formula of the ion that is formed. Write the formula of the ion. This is question number 3. Question number 3, you are asked to write the formula of the ion. Write the formula of the ion. You write the formula of the ion, number 1. You write the formula of the ion of W, and then the formula of the ion of Z. So we know that W is in group 1. So W has got 1 electron in its outermost shell. Therefore, for W to become stable, W will lose 1 electron. So if W loses W minus 1 electron, then we have W plus. This is the ion. And then Z is in group 7. Z needs 1 electron. So we will have Z plus 1 electron. Then this becomes Z minus. So this is telling us that we have 1 more proton than electron, because 1 electron is lost. So this is telling us that we have 1 more electron than proton, because 1 electron is gained. 1 electron is gained. So the ions are 1, we have W plus, then 2, we have Z minus. These are the ions. Then another question comes that we have elements. We have the atomic number, the atomic number of P is 13. The atomic number of P is 13. A is that write the electronic configuration. Write the electronic configuration of P. To which group in the periodic table does P belong? To which group in the periodic table does P belong? To which group in the periodic table does P belong? Then lastly, state the bonding. State the bonding in the oxide of P. That is, when P reacts with oxygen, what type of bond is going to be formed? the atomic number of P is 13. So P is an element with atomic number 13. You need to write the electronic configuration of P, then to which group in the periodic table does P belong, then instead the bonding in the oxide of P. Let us start by number 1. We start by question 1. We have the atomic number of P is 13. So if we have P 13, the electronic configuration will be like this. K, the first shell, always takes 2. Then L, the second energy level, it takes 8. Then we have M, the third energy level. So this is 2 plus 8 is 10. We will be left with 3. So KLM 283. This gives us a total of 13. Then, to which group in the periodic table does P belong? To which group in the periodic table does P belong? So you look at the number of electrons in the outermost energy level, because elements are placed in groups based on the number of electrons in their outermost energy level. So the number of electrons in the outermost energy level of P is 3. This indicates that P belongs to group 3 in the what? In the periodic table. P belongs to group 3 in the periodic table. Then when we come to the periodic table, when we look at members of group 3, so the element that is having 13 is what? Is aluminum. So automatically we know that P is aluminum. Instead, the bonding in the oxide of P. Instead, the bonding in the oxide of P. You cannot state the type of bonding unless you write the chemical formula of the oxide. So if we have the compound is P oxide. So before we start writing, let us start by writing the chemical formula. We said P is in group 3. P has got the valency of 3. And oxygen has got the valency of 2. So the first step is the second step is we exchange the valencies. We exchange them and then we write them at the bottom. So that we have P. So if we bring the valency of oxygen to P, we will have 2 atoms of P plus O. Then we bring the valency of P to O, P2O3. So that is 2 atoms of P reacting with 3 atoms of oxygen. Then for us to know the kind of bonding, this goes back to whether the electrons are shared or gaining and losing. So we have P can easily lose 3. And then oxygen needs 2. But this compound is telling us that we have 2 atoms of P. So 2 atoms of P can lose 3 electrons. Each one can lose 3 electrons. That is a total of 6. And this 6 can be gained with 3 oxygen atoms, because each oxygen atom is needing 2. So which means that this compound is formed as a result of P losing electrons that are gained by oxygen. So the nature of bonding will be ionic bonding. because ionic bonding is a bond that is formed as a result of losing and gaining of electrons. Losing and gaining of electrons. So we have the nature of bonding, the type of bonding that will result in the oxide of P. So the nature of bonding that will result from the oxide of P is ionic bonding. Because it is formed as a result of losing and gaining of electrons. So this is a brief exercise to summarize for us the topic of periodic table. So I have come to the end, and then I have winded up every topic the topics that are supposed to be covered in the area of periodic table. So dear learners, we have come to the end of our lesson. See you in the next lesson. Bye bye.